All right, let's continue 7.2, where we're covering how to do antiderivatives of trig functions with powers. I put the rest of the possibilities into a chart here. There's the first two columns are basically review. The method for doing them is just using trig identities. So it's whenever you have sines and cosines multiplied together and even powers. So a sine to the 4 or a sine to the 4 and a cosine to the 6. Then the first thing to do is just to break down those powers until everything is squared. So if you have sine to the 4, that becomes sine squared x all squared. And then I'll use one of the trig identities, and specifically I'll just replace sine squared x with 1 minus cosine 2x over 2. And in the second example, same thing, and then I had cosine to the 6. I made that cosine squared all cubed. I'll replace cosine squared with 1 plus cosine 2x over 2. After that, it's a calc 1 problem, but it's tedious. You'll have to do a bunch of FOIL and find all the antiderivatives of cosine 2x, which isn't hard to do, but you do have to do a tiny u substitution on the 2x. And you should just know that those are doable. I won't put one of those on the test because it just takes a lot of extra foiling out and doing calc 1. So they're mostly there for comparison to the kind that are going to be on the test in this class. And these are u substitution, but it's a clever u substitution that they saved for chapter 7. These you see when there's a sine or a cosine to an odd power. So sine to the 7x is in that first example, and cosine to the 5x is in the second example. Then what you do first is pull out a copy so that nothing is left but the even powers and one plain sine or cosine. So when I have sine to the 7, I pull out a sine x, and so sine to the 7 becomes sine to the 6 times sine x. Leave cosine as it is. Then I do the same thing as I did before, where I replace, I break down even powers into squares. So I'll have sine squared cubed. I would also take that cosine to the 4x and turn it into cosine squared squared. Although I could leave it the way it is. Yeah, just leave that cosine to the 4x the way it is, actually. Because then what you get to use, well, first I'll be able to put everything in terms of cosine, because I'll be able to write sine squared x as 1 minus cosine squared x. That's just the Pythagorean identity. And then the u substitution comes out super nicely. You let u equal cosine x. So that's the other trig function, not the one that was the odd power to begin with, but since sine was an odd power to begin with, I use cosine as the u. Then du is negative sine x dx, and that sine I pulled out from the odd power is the is in the perfect place to be replaced with du. I will leave that one here, and I'll work it out on the board so you can see the rest of the steps. But let's look at the last example too, which I'll also do on the chalkboard. It had cosine to the 5, so I pull out one of those and make it cosine to the 4 times cosine. Then you can do some rewriting to make sure that the cosine to the 4 is all in terms of sine. You do that in 2 steps. First, make it cosine squared squared, and then cosine squared is 1 minus sine squared. And then the u substitution this time, since cosine was the odd power to begin with, is sine x, and du is cosine x. So the cosine x I pulled out is perfect for the u substitution. And let's finish those up on the chalkboard.